All right, let's think about starting with a problem that looks like this. We have, let's see, my pointer, I have negative 5 x squared y all raised to the third power. So if we think about this, this is really like negative 5 x squared y times negative 5 x squared y, and then one more, right, because it's the third power. Oh, don't forget my squared in there. Okay, so then we would have to multiply this out, right? So we'd have negative 5 times negative 5 times negative 5. Well, what's that? Negative 5 times negative 5 times negative 5. I know that is negative 125. Now, next, I should look at my x's. I have x squared times x squared. Well, we know the rule is x, and we're adding these, right? 2 plus 2 plus 2. So that would be 2 plus 2 plus 2 is 4, 6, right? So that instead, I could say, instead of 2 plus 2, I'm going to call that x to the 6th power. So 6 here. Whoops, not beautiful. All right, now the last one is the y. We need the y and the y and the y. Well, we know y times y times y. That's really like a 1 there, right? So that would be y to the 1 plus 1 plus 1. And if we erase that, 1 plus 1 was 1. That is y to the third power, right? So this is one way to do it. This is one way to think about it. So now let's think about another way. Let's get rid of this here. Move that down, shrink it out of the way. Don't forget it. There is a rule, right? So here's the rule. We can say it's times this here. So negative 5 is really to the first power, right? 1. And we're going to say it's times the outside third power. So, and then let's think about the next one. X squared. Whoops, right there. We have x squared. I want that to be black. Undo. Hang on. Let's make that black. All right. We have x squared times that. And then last, we have this one here, y, which we know is a 1. So y, 1 times the third power. So if we end up doing that, that would be, let's rewrite it. We have negative 5 to the third power, right? 1 times 3. And then we have to think about this one here. X 2 times 3 is 6, right? So x to the 6th power. And then we would have to think about the last one, 1 times 3. That would be y to the third power. Now, does that look like our answer from before? Here's this answer. Is that the same? Well, not quite yet, right? What's different? Our x to the 6th power here, our x to the 6th power is good. Our y to the third power is the same as down here. But we haven't done out our negative 5 to the third power. So we can do that, right? So we have negative 5 times negative 5 times negative 5. Well, that would equal negative 125 x to the 6th power, y to the third power. Does that make sense? We can try another one. Here, let's shrink this whole thing. Uh-oh, there I go too. Let me grab this. Move the whole thing out of the way. Move that out of the way. Move me back here. Let's just try one more. So what if we have 3y, oh, so not pretty, to the 4th power, right? So this would be times. Well, what we don't write is that there's a little 1 there. So this would be 3 to the 1 times 4. And then this really ugly y here, right? This is my y to the 4th power. So let's write that, y. And we didn't write that there was a 1 on this guy too, right? So 1 times 4. So when I'm all said and done, this would be 3 to the 4th power, and then y to the 4th power. Well, this is 3 times 3 times 3 times 3. That's 9, 9. So this would become 9 times 9. This would be 81y to the 4th power. If you can read that. Okay, good. So that's one. You try some on your own. And as always, shoot me an email if you have any questions. Thanks.